All right, well, it's 10:20 by my watch, so let's get started. Thanks for hanging out. Welcome to, I guess, session one of NDC Sydney in room one. Thank you for joining me, um, or joining from wherever you are, which is easier. If you want to turn on your cameras, that's great. I can see you over there and you can smile and nod. And if you don't, that's cool too. If you have any questions, feel free to ask in the Slack channel. I've got that open as well. And that's a bit easier to track than the WebEx chat. But let's get started. Let's talk about source generators. Let's talk about writing code to write some code. So source generation in general is a concept that is very, I'll say it might not be familiar to every developer, but every developer pretty much uses it, even if they don't know. And I think it's an idea that will appeal to every developer because it's all about automation. It's all about taking something you don't want to do, in this case, writing some code, and making a computer do it, which is maybe kind of what we're all sort of in this job for anyway. And as I sort of said, we all probably use source generation in general terms every day. If you've got a .NET project that SDK style .NET project that doesn't have an assembly info, for example, that is generated at build time by a source generator. It's not a C#9 source generator that I'm going to be talking about mainly, but it's still source generation. If you've got a regex file or a razor file or even an ASPX web forms file, all of those things have source generation as part of how they work. It's all about automating some stuff. In the case of regexes and razor files and things, it's to save you from having to write this class that represents what you want your output to be. It's generated. So that's the general concept, and there's a few different ways that that works currently. So let's quickly do a bit of background on what these things look like. So at a very high level, this is very high level, as you can see, this is what happens when you build your project. You have your C# files, which are handwritten by you, presumably. They go into the compiler and that produces a DLL. Cool, makes sense. So the two ways that source generation can work now, and by now being before C#9, so there's two ways. The first way is before the compilation. And so you might see things like MS build tasks being used for this. There's tools like CodeSmith, which is one I used to use 15 years ago. And then there's all sorts of other options as well. There's single file generators built into Visual Studio. There's lots of different options here. But basically what they do is they will look at the files on your disk and generate some code based off them. So this is where the regex or the ASP razor file generation comes in. They'll look at those files on disk, generate some C code, C# code, and that all goes to the compiler together. And the compiler essentially doesn't know which code you wrote versus which code was written by someone else, which doesn't matter, but that's essentially, to the compiler, this is all just code, one big lump of code. And it all comes into your DLL. The other way you can do source generation now is after the compilation. This is where there's tools like PostSharp you might have heard of, or Fody, and these work at a very different level. These work at the IL level. So your C# code is converted to IL, that's what puts in the DLL. These tools work by changing the IL directly. They're called IL weavers usually. And the way these work is very different, and Fody and PostSharp sort of work as tools that allow you to make that job easier, right? So you don't have to actually use IL, you can write C# code that uses their libraries. But essentially the way these work is, I would say this is the most powerful option, right? These can change the IL of any DLL you produce or even any DLL you reference. If we forget for a second about things like code signing and strong naming and certificates and whatever, we assume there's no security in the world because it's easier. These tools could change any DLL in your whole project. So we kind of have these two extremes at the moment, where we have this extreme power on the right-hand side for post-compilation generation, and then we have, generally speaking, the easier to use options before the compiler gets to it. So what's new and what I'm going to be focusing on from now on is C# 9 brings its own source generation feature into it. And this is the first sort of inbuilt, well, it's the first generation option built into the compiler. There's various options built into Visual Studio and other Microsoft products, things like T4 templates, etc. But this one's built into the compiler. So before we talk about that, though, let's just talk quickly about what the compiler does. So digging into this black box of a compiler, or a pink box of a compiler, what happens when your C# files are compiled? So the compiler is made up of phases. There's about 5 of them, but there's 3 that are sort of relevant here. The first thing that happens to your C# files is they go through the parse phase. And this is where the text of your files, the C# code itself, gets parsed and converted into a syntax tree. Now, this is a concrete syntax tree for the current C# compiler, but don't worry about whether that's what that means. It's just a syntax tree. It is a tree representation of all of the bits of your code. That syntax tree is then sent into the compile phase. And from that, it becomes, or we get, a compilation. The compilation is adding in all of the rich information about the type system. So, for example, if you had a variable that was declared as a string with a lowercase s, well, the parser knows that that's the string keyword in C#, so that's going to be a keyword node. But if you use a capital S, the parser doesn't know what that means. It's just a type called string. It has no idea where it comes from. The compilation is what adds in that type information to say, this is a system.string from mscalllib.dll or whatever it is. Oops. And so then that compilation goes to the emit phase and it becomes IL. And that's what gets sent to our DLL. So that's our high-level view of the compiler. Let's add source generators into the mix. So a source generator is something you tell the compiler about, you provide, essentially. You say, hello, please use this source generator for me. What happens now is your code goes into the parse phase, produces a syntax tree, goes into compile, syntax tree becomes a compilation. And what happens now is different. Now what happens is the compilation and those syntax trees get sent across to the source generator. So in the middle of the compiler, we are now able to provide this library that says, hey, while you're compiling my other code over here, also run this code that I'm giving you, or this library. The source generator then generates source, obviously, which is a string. It's just a string of C# code. So of course, the string has to go through the parse phase, becomes a syntax tree. That syntax tree becomes a compilation. We combine that compilation with the one from our project and we mush them together. And then that final result of all of this gets sent through the emit phase, becomes IL, and gets sent out to your project. So the source generator allows you to hook into the compiler pipeline and allows you to add in more code that will be sort of become part of the DLL. The source generator itself doesn't move. It doesn't ever become part of the DLL. You don't have to distribute it. It's only at compile time. So some potentially frequently asked questions, things that seem to come up a lot, just to preempt maybe some questions. So does the source you generate exist on disk? This is sort of the first, seems to be the first reaction everyone has to these things is, okay, how do I see these files? And it's a bit weird because by default you can't. They don't exist. This is all happening in memory in the compiler. You're writing strings and they're getting converted to memory streams and that's it. There is an option to emit them and it's good for debugging, but it's not something that you use. It's an anti-pattern if you want to try and read those generated files and decide if you should run, etc., whatever. You're supposed to let the compiler work out whether you should run or not. Can you have multiple source generators? Absolutely, but they each have to be independent. You cannot have source generators that rely on other source generators. So you can't build up this layered approach. And this is a challenge for some sort of crazy out there designs. And it'll be interesting to see. This is a space that I think might change. There's some proposals around at the moment for having 2 levels of source generators. So you could opt into being the first level and then the second level could depend on the first one. But we'll see. But yeah, this does mean that if you want to have, a half a dozen different source generators for your project because you've got all these crazy ideas, that's great, but you can't build upon them at the moment. The next question that everyone asks when they start to write a source generator especially is, how come I have to make strings of C# code? This seems crazy. And it kind of is crazy, but it also kind of makes sense. So there are higher level concepts for code, right? There's syntax trees. We just talked about them. That's what you get to use when you're writing a source generator. But allowing you to produce a syntax tree directly is a very big, well, it's not a problem, but it's a big challenge. The C# compiler, it turns out, is really good at compiling C# code from a blob of C#, but compiling arbitrary syntax trees is just not, it's not as well tested, and it's pretty easy to break the compiler or just have the compiler produce code that is not what you expect. Because, and I'll show you this in a minute, but the syntax trees in C#, the reason they're called concrete syntax trees is because they're super detailed. They contain every single character of your C# file, including all the white space and all the comments and everything. And in fact, they go two ways, if you like. From a syntax tree, you can produce the code that produced it, and it is identical. And so because of that, the syntax trees needed to be valid C# are really detailed. And they're actually a little bit of a pain to produce. And then can they change code? So this is the really big kind of a gotcha about C# source generators, or at least a major difference between the existing options and this new option. They cannot change existing code. You cannot modify anything. You can only add new code. So if you remember that little diagram, your C# files produce a syntax tree, they produce a compilation, and then the source generator produces more code that gets added to that compilation. There's no changing. Now, this is another one of those things where I think there's a bunch of ideas people might have for source generators, and you get to this point where, oh, I can't change code, and all your ideas, some of your ideas just fall on the floor. So this is a bit of a challenge, but this is also kind of why we have them. These things have been talked about and discussed in the compiler planning for years, and it is just a huge hurdle to get over if they have to change code. So they can only add, but there's a few ways you can sort of work with that. So we'll cover that. And then the IDE experience, the Visual Studio in the latest preview, so 16.8 preview 3 and above, it's a pretty good experience if you're using source generators. It's not as good for writing source generators. There will be more work coming in that area, but for now, there's a few rough edges. And that's basically just because Visual Studio, being .NET Framework, once it loads your source generator, it can't unload it, and therefore it can't load the next version with your changes. So there's a few little things there, but I can show you that too. All right, so what can you do with them? So this is definitely just my opinion, but I sort of see source generators falling into three main buckets. So the first one is performance, essentially. In a lot of cases where you've got code that uses reflection, you can change them to be source generators, and you can inspect that code at compile time instead of runtime, and you get a huge performance boost. A couple of examples there in case anyone wants to refer back for any questions later, that's fine. I'll talk through the WinForms enum validator that I wrote, as the second half of this talk is just going to be talking through it. So, but yeah, getting rid of reflection is a huge boost to performance. And if it's possible, moving all of that work onto the compiler or at compile time is a huge win. The other one is the automatic to automate processing of external files. So this could be things like serializers, XML serializers, JSON serializers, or deserializers. There's a source generator in Roslyn that generates so from the C# grammar file, the file that describes the language, we generate a bunch of code for accessing that, right? Basically, all those syntax tree node classes are all generated. That's a good example. Anything you provide with additional files in your project file can be seen by source generators, so you can automate the processing of those things. And again, sometimes that's just a matter of moving work from runtime to compile time, but sometimes it's a bit more than that too. And then finally, there's just the sort of the obvious one of, I don't want to type this code all the time, so make someone else do it for me. Things where I've used source generation in the past for this is things like custom ORMs, or this is sort of what, if you've used the entity framework or linked to SQL designers in Visual Studio, where you draw the tables out and link them up, etc. All of that generation that generates classes and properties and things, whatever, that's pretty boring stuff. So generating that is potentially a good win. Things like, mapping and whatever else. So there's a few other little things that we can do with source generators. I'm going to run through quickly. Source generators can report diagnostics, which is a fancy way of saying build errors. So as part of the running of the source generator, you can essentially stop the build of the project that's consuming it. So this is a good way to add in validation around what you're generating. It's tempting to also add in validation of the project you're compiling, but try not to do that because that's what Roslyn analyzers are for. But they do perform the same job. So your generator can report a diagnostic, it'll appear in the build log, it'll appear in Visual Studio. Everything that uses compiler diagnostics just sees this as another compiler error. It doesn't know that it came from your code instead of the compiler. As I briefly mentioned, they can access additional files. So any file in your project that you put in the additional files group in your source generator, you can just iterate through them and go nuts. And there's a link at the bottom there, which I'm not going to talk through, but it's an interesting idea, not for production use probably, but it's essentially a C# project. You using the source generator to create a C# project that has no C# in it, but just has additional files, then those additional files are processed by a source generator. And so my friend Scott wrote a source generator that transpiled a language, essentially a non.NET language, write the parser as a source generator, and then output C#. Anyway, a bit crazy, but it works. Usage notes, yes, that's right, that's what's next. So some other things around source generators that are good to mention. So I said they can't change code, and that's really important. So one of the mechanisms you can use in C# to allow your source generator to sort of access the, into the middle of where your real code is, because it can't change it, is to use partial methods. And so because of this and because of source generators, partial methods got a bit of a boost in C#9. So before C#9, this is what partial methods look like. You would have partial void method. You would call that method from some other bit of code. And then somewhere, be it handwritten or not, you would define the implementation of that method. And the way this worked before C#9 was if you didn't provide that implementation ever, then that method call just went away. It was though it never existed. So if you assume that I don't have this bottom half of this slide, this line of code here would just not be compiled into the DLL. And so because that can happen, and because that line can be removed by the compiler, there was a lot of restrictions on partial methods. So you couldn't return anything from them, couldn't have out parameters, right? Because if you're removing that line of code, well, what would the return type be? What would the value be? All those sort of things. And you couldn't have access modifiers. So they couldn't be public because it might not exist. They actually couldn't be private either. They couldn't be anything. You literally weren't allowed to type in an access modifier. But so to make these more useful for source generators in C#9, basically all of those rules have been flipped on their head. So they can have return types now. They can have out parameters. They can have access modifiers. But if you have any one of those things, then you have to provide an implementation. So basically, you can now make them real methods, but if you want them to be real, they have to exist, essentially. They're not optional anymore. And so this means that you can define your method signature for a method that will exist in future. You can call it, although I should have updated this slide because clearly that's not the right number of parameters anymore, but you can call it and know it will be there, and then your source generator can fill in the body, essentially. So this is a way to sort of not really edit code, but put a spot to say, hey, source generator, here's where I want you to fill in the gaps. So you provide these little holes in your code, knowing that something will come and fill them in later. All right. So quickly, how do we actually reference them and how do we create them? They're pretty simple. So up the top left, those two little snippets of project file is the two ways that you can reference them. Essentially, they're referenced the exact same way that you reference an analyzer if you're doing any custom Roslyn analyzer work at the moment. So one is just with a direct DLL reference, and this normally, would be hidden away via a NuGet package, obviously. You can reference them as a project. So if you've got a source generator in your solution along with your actual project, you can just reference it that way. There's a little bit of extra little guff here. So reference output assembly equals false, which basically says this isn't a dependency that you want to reference. It's not a library of code I'm going to be using. It's just something I want to build first. And then the output item type is saying, well, instead of being a normal reference, this is an analyzer reference. And then to actually create a source generator is really straightforward, which is the bottom two pictures, if you like. So the biggest thing to remember, they have to be .NET Standard 2.0. They cannot be any other target framework. And that's just because the compiler is cross-platform. So .NET Standard 2 will work anywhere. It's safe. And then you reference those two packages, the code analysis.analyzers and the C# workspaces. I actually think only one of them is needed to actually create a source generator, but you kind of can't do much with it if you don't have the other one. But so you reference those packages, and to actually create a source generator, it's pretty simple. You create a class, you put the generator attribute on it, you implement iSource generator, and then there are two methods. There's an initialize method and an execute method, and that's it. And if you look at that picture, this is like the world's simplest source generator. You create some C# code in a string, as mentioned. So this is a class called foo. And then, I've got a null check there. And then you just call the add source method. You say, hey, pretend this file exists, and here's the source for it. The file, as I say, doesn't really exist. The name, see how that says hint name? The name of the actual file that's produced has a couple of GUIDs in it, so it's not going to clash with anything. You can, you can't create the same file name in the same generator by calling add source, but you don't have to worry about conflicts. Like, it's not real. But essentially that's it. That's all you do to generate code. And if you use that as a source generator, then your real project will be able to access a class called foo and do nothing with it. All right, so some of the things you want to do with your source generators. And this, I'm just going to whip through these slides really quickly because I'll show you in a more realistic scenario. So reading syntax. If you're doing anything about, say, removing runtime reflection or generating, automating code, you probably want to read the source code of the project that is using your source generator. And so the way you do that is with the Roslyn API. There's lots of great talks and blog posts and all sorts of things on how to do that with the Roslyn API. I'm not going to go into it. But just as a quick tips, there's a couple of cool tools that I recommend. So the syntax visualizer is that picture on the right-hand side. It's built into Visual Studio if you tick on the optional compiler SDK component in the installer. And as you're clicking around your C# code in VS, that's going to show you what the syntax tree looks like for that spot in the code. And this is really useful because as you start to inspect the code, you have to know how to do that essentially, right? You have to know which bits to pull out. So this syntax tree here, excuse me, this is for a simple, this bit of code here, this main. And so you can see we have a namespace, we have a class declaration, we have an attribute list, which may or may not be empty. There's keywords, there's all sorts of, but the syntax tree in general, as I said before, is really detailed. So having a tool to let you inspect what is in the syntax tree is super useful. If you don't have VS or you don't want to use it for this, SharpLab is a website that has the exact same feature. Basically shows you the syntax tree of any code you write. SharpLab in general is awesome and does some other things that are great too. But that's another quick way to see the syntax tree so that you need to know what you're looking for essentially. So let's say you were looking for every method defined and you wanted to do something with it. Well, you're going to be looking for these method declarations, but of course they're inside class declarations and they're inside namespace declarations, and it gets kind of complex as you sort of drill in, and there's lots of options around things you could drill into, and there's lots of casting you often need to do. So a method declaration might have a body, but it also might have an expression body, and those are two different things. So being able to just sort of poke around the syntax trees is really useful. And that's actually what I've got as the third point there, trial and error. By far and away the biggest or the most useful tool that I use for this sort of thing is the debugger inside VS, because if I get any kind of syntax node, I can just look at it in the watch window and I can start to drill into it. Super useful. And then reading symbols is the other side of looking at code. So syntax is what the code looks like in the C#, and then symbols is that meaning that the compiler adds, the compilation adds. So this is where you find out what types things are, etc. And there's a couple of sort of hints here, just very quickly. So there's something called the global namespace. This has everything that the compiler or everything the compilation needs to compile your code. So that includes every reference, dependency, everything in the world. This is the entire world as far as the compiler is concerned. So if you want to pull any information about the code you're looking at, it will be in the global namespace, guaranteed. Because if it's not there, then the code doesn't compile. Get type by metadata name is the sort of shortcut for reading that info. This is where you pass into that method system.string, and it gives you back the type for system.string. This is useful if you want to find things tagged with an attribute. You need a reference to the type of the attribute, so you just put in that namespace and away you go. Get semantic model is how you get the essentially the symbol information for this block of syntax that you have. So there's always these two worlds of syntax and symbols, and get semantic model is how you sort of leap from one to the other. This is where you say, hey, I've found this method declaration. Great. Give me the semantic model for that so I can start to see what types it returns, what types of parameters does it have, etc. You then call get symbol info on the semantic model to find out the type information. And then the syntax visualizer does have some symbol stuff built in. It doesn't work very well, although there was a PR a couple of weeks ago to hopefully fix some of the issues. But again, trial and error works really well here. If you've got some bit of syntax, call get symbol info on it, you'll get an I symbol, and then just look at that in the watch window, because it could be an I type symbol or an I namespace symbol or an I method symbol, whatever it is. But the debugger, the watch window will show you that info. You can drill into the properties, you can just start to get a feel. And it's relatively straightforward once you start to do this, because you're familiar, presumably, with the code that is being analyzed. So yeah. And then generating syntax. This is where things get interesting, because this is where it can be frustrating that you have to use strings. But the flip side of that is using any kind of higher level thing. Well, the higher level classes that the compiler gives you are syntax nodes. And so on the left there, excuse me, which maybe you can't even see because it's so tiny, because there's so much to it. That is the code necessary to produce that code on the right-hand side. This all comes from a website called Roslyn Quota, link there down the bottom. So with Roslyn Quota, you put in that block of code on the right, you click generate, and it creates you this code that's on the left. So that's easy enough to do. And if you want to use a higher level concept, you can do that. But as you can see, it's very detailed. That actually, on the left, it even leaves out some stuff that is not necessary. So it actually can get even longer if you include everything. But the trap here, so the very last line of this little snippet, which maybe you can't see, but maybe you can, it says normalize white space. And that's calling a method in Roslyn that basically says, hey, here's some code, here's some syntax nodes I've generated. Now make them, human readable. The trap is, if you don't do that normalized white space, this is what that exact same code produces without the normalized white space code. And as you can see, this is not valid C#. So this is where if you were providing a syntax tree to the compiler directly, you could run into all sorts of problems because you could give it invalid code. So anyway, that's just something to keep in mind. You can use this if you want. it really just depends how complicated your generator gets and that. There is a question in the Slack. What are the real use case scenarios? I will run through a few of those in just a second. Good question. And then debugging a source generator. I think this is maybe the last slide before we just chat a bit. Debugging the source generator is a little bit of a challenge. So if you want to debug your source generator in a real project that you're really using, then you can put in a call to debugger.launch in the source generator. That will pop up a window and say, hey, which Visual Studio do you want to use? And it does all work, and you can put breakpoints in and everything worked great. The issue is that happens every time there's a compile. And with Visual Studio, every time you type on the keyboard, it's going to be compiling your code. So if it gets far enough to run your generator, you might end up getting flooded with these dialogues. So there's some edges there. There is a class in Roslyn called Generator Driver, which is designed for running source generators. And so you can use that to create a test app or unit tests. Personally, I find that to be the way to go. So there's a couple of links there. So sourcegen.dev, I will show you in a minute. But that's essentially a tool I wrote just to try to make this stuff a bit easier to reason about really quickly when you're just starting out or when you're making minor changes. There's also a link there to a source generator template repo that I made. And that's essentially a very simple source generator, a very simple unit test project for the source generator, a simple console app that when you run it, it just spits out the code the source generator generated, and a simple app that uses the source generator as a generator. So it's basically all 4 types of projects you could want. And so that's sort of what I do as my starting point. I will grab that repo, copy it, duplicate it, rename it to whatever it is, and that's where I start working on things. And that way you can press F5 and debug as normal. And then Kitatas by Chris is the final link there. So Chris is the compiler dev who actually wrote pretty much all of the source generator infrastructure in the compiler. Kitatas is his project for essentially allowing F5 debugging of source generators really easily. It's a .NET SDK and global tool. It's very tricky, but really, really clever solution to the problem. I think that's it. So let's whip across to sourcegen.dev. So the question was, is it more productivity enhancements rather than performance improvements? So that's a really good question, and I can hopefully answer all of these things, because it can be both, or it can be everything. So let me jump into one example here. So this is sourcegen.dev. I built this because I was getting frustrated at using and trying to write source generators and trying to reason about them. And I built this. I'm very glad to say that it's almost completely unnecessary now because Visual Studio has caught up, which is great because I don't want to pay to renew the domain name. But it is just sourcegen.dev if you want to muck around. If you want to go there now and play along, that's fine. So what this is, as you can see, is 4 text boxes. I am not the greatest web designer in the world. I freely admit it. The theory is, in this box on the top left is my program code. This is the code of my application, or whatever it is. This is the thing that's going to use the generator. This is the thing that's going to receive the generated code, if you like. On the top right, we have the text of the generator itself. So this is what does the work. This is going to look through my code and analyze it, etc. This then generates the output that is in the bottom right. This is the code that was generated. So you can see that here there's an attribute, and if we scroll up here, you can see this is got an attribute. The generated output and the program code are then the 2 things that are combined together, and then this is the output of running the program. So that's basically how this works. So back to the question, thank you, Mohammed. This would be an example of a productivity enhancement. So this is an auto-notify sample. This is not written by me. This was written by Chris on the compiler team. The theory here is, very often in WinForms or in WPF, a lot of desktop apps, you want to implement iNotify property changed. iNotify property changed is a very simple interface that has a property changed event. So every time a property is changed, you want to fire an event. So someone listening to that event can know when things about your class change. And it gets kind of tedious because you can't use, so for example, let me just turn off auto refresh so it doesn't compile as I type. But so if I type in here and I say, public string name, I'm using an auto property here, so I can't easily implement iNotify property change because I need to basically put some code in the setter. If I expand this setter out and I can now, fire my on property change event, well, that's great. But now I need a field to store my property in, and I have to convert this from a auto property to a full property. And so it sort of adds this cost of, having to write a bunch more code, which is not very exciting code. It's probably not going to be buggy code, but you never know, right? So this is where, as a productivity enhancement, what you can do with this generator is you define a field and you just put this attribute on. You say, hello, I'd like to be notified when this field changed. And what happens is down here, if we look, the source generator is generating the full property for this field, returning the value. And obviously this, we've already defined the field, so this one doesn't have to. And then when the field is set, we can see it just fires this property changed event. So this is a really simple example where, without any risk of, typos or anything else, we can implement iNotify property changed at almost no effort. And if we scroll down in this program a bit here, you can see here, we're accessing that text property from that view model. The text property doesn't exist, right? It is being generated. So that's where this is a partial class. We are generating the other half of this class. So this is a huge property boost. You can also do cool things like here, we're specifying the property name of this property should be count. So even though the field is amount, if we scroll down in our generated output, we can see the count property returns the amount field. So you can, tweak and adjust the generator. Now, obviously that's a feature of this generator, not of source generators in general, but these are the types of things you can do. And then this runs. And so if we comment out this auto notify property, oops, I turned off auto refresh. So now what's going to happen is our program's not going to build. So this is, I would still class this as a productivity enhancement. What's happened here is, as a developer, I've left off this attribute. You can see the generator has still worked. It's still run my generation. It's still generated my count property, but it hasn't generated any other property. So here, this line of code here, this vm.text is line 24, right? This is where the error is because there is no text property. I didn't define it, and I didn't define the attribute that tells the source generator to define it. So I still count, this one's a little bit complicated, convoluted, I should say, but I still count this as a productivity enhancement because this is ensuring you don't forget, essentially, right? You can imagine a system that worked at runtime looking for these attributes. If you forget an attribute off one property and then someone tries to use that mechanism in some way, that would have to be an exception at runtime. So at runtime, your app's going to blow up and say, hey, some developer forgot to add this line of code. Source generators, I get to do that validation at compile time. So I get to break the build, which means you can't forget. Before we switch over to Visual Studio, one last thing is, or another example is this. This is a DI generator that I wrote just for a side project. So it's only for my needs. It's not very full featured, but I think it's an interesting concept, and it's an interesting way to look at how you have to think to write a source generator. Or, oh, I need to turn off auto refresh. Not how you have to think, but what you can do. So what this is a service locator, right? Normally with DI, you would build up a container, a DI container. You would say, hey, when someone asks for an IFOO, right down here we have our interfaces. When someone asks for an IFOO, use a foo, right? You would add a scoped or add transient or add singleton, whatever you do. The way this works is this source generator sees that you want to call get service and pass in an IFOO. And as you can see down here in the generated code, whenever you call get service, this returns my foo class, right? I think this is a really cool example of how source generators can, well, this is performance, more on the performance side for me, but source generators can produce the most minimal code possible. So if you were writing a service locator, you would presumably want to check and say, right, well, what type do we want to construct? Oh, okay, well, they want an IFOO, right? Well, then I will construct a foo. But you notice there's no if statements here. That's because this source generator knows what my code looks like, and it knows that I'm only ever calling get service asking for an IFOO. So there's no need for any if statements, right? If I ask for something else, so here I'm going to ask for an I bar, and I refresh, my source generator will now see 2 calls, and so now it knows to put in an if statement. So this is definitely performance, but I think this is also productivity, because in essence, I'm not having to write this library code that sort of has to cater for all possible cases. I can write, or I can generate the simplest code possible. So obviously there's going to be some performance wins there. But I think it's also a little bit of both. And so this one, now we're asking for 2 different types. So now it does have to do an if. So it checks if you want an IFOO, it's going to give you the foo. But again, there's no other if here. We know that there's only 2 types being asked for, so we can just go ahead and give you the bar. This time it also generated lazies, because otherwise it would be slightly inefficient if when you ask for a foo, it initialized both fields, right? And you can get down into the weeds and control that stuff as much or as little as you like. In fact, I think I put in a couple of little booleans here to control this. So I can turn off this, and then now it just constructs objects. And if that's better for your needs, then great, do that. You can control exactly what this does, because of course you're authoring this generator. What else can I do? I can make this say that it's transient. So every time someone asks for a foo, I want a new one every time. And so this now generates just a constructor call, right? So it's the minimal code necessary to do exactly the job that my consuming code needs. We can also get build errors, right? So now I'm asking for an IBAS, and there is nothing that implements this. So again, instead of a runtime exception because, hey, you haven't filled in the container properly, or you forgot to wire this up, or you forgot to reference this DLL, I get a build time failure that says this was not going to work. I don't know when it was going to fail, but it was definitely going to fail at runtime. So it doesn't even let you get that far, which I think is a super powerful thing. So that's the DI example. Let's go over to Visual Studio for a minute. So yeah, if there's any questions on that or anything else, please feel free to ask. What I thought I'd do now is just sort of run through a little bit end to end of a source generator that I wrote, or kind of still working, the PR is still open, to improve. I guess in this case, this is definitely performance gain, although realistically it's probably about the same performance-wise as the existing solution, most cases. This is one that I would definitely class as a productivity gain, but this one's a good one, I think, for this is essentially removing technical debt in a way. So the background here is the WinForms project WinForms in general has lots of public API that takes in enums, right? Enums work really well in the property grid, in the designer, and so just historically they were built up, I guess. And so there's a lot of public API that take enums, which is great in theory, but as I suspect you know, in C#, you can pass any old integer to any enum, and the compiler will let you. Right? You just cast the int and away you go. An enum is not a strict set of values at the moment. And so there was a bunch of validation code in WinForms to ensure that all of the values passed to all these public API were correct. So this is the actual validation code from the WinForms repo. And so you can see is enum valid, takes in an enum, takes in a value, the current value being set, takes in a minimum maximum value. This is the bounds of that enum, if you like. The check itself for validity is very straightforward. It's just less than or equal to, or greater than or equal to. And then in debug, there's some code here. I'll talk about that in a second. There was a bunch of other overloads for this. So they have a bunch of enums where it's not a flags enum, but the values are powers of 2. So there's this max number of bits on to validate that at the end of casting, you should only have 1 bit on. So this does a bit more code here, this bit operations.pop count. Still probably fast, but that's okay. When it's a flags enum, just use the mask, that's okay. We just have to pass this in. When it's a non-sequential enum though, things get a bit worse. So enum.getValues is using reflection. That's not ideal. It does only happen in debug mode though, so maybe it's okay, but now we've got to loop through and check all these things. This is starting to get a bit worse, right? And then if you look at all these hash if debug things, what these do, if we go to them, is these do heaps more validation, again, only in debug mode. But all of these things do a bunch of validation because the way you have to call these enum valid methods is you pass in the current value you're validating, but then you have to pass in all of the possible values for this enum, or you have to pass in all of the possible values for this masked enum, or you have to pass in what is the minimum and maximum value for this enum. So there's this huge technical debt where every time you add a value to an enum, you have to remember to update all these validation calls. If you don't, there's now this debug code that's going to add validation that's going to throw an exception at debug time, if you're running in debug, of course. And then it's actually funny because of the complexity of the debug validation, there's also this maximum cache size here where it caches some of the debug information, but eventually that cache gets too big. And so there's all these layers and layers of debt. So what we can do, though, is we can completely replace that. So what I did after talking to a friend of mine on the WinForms team, because they got a PR to simplify all their enum validation code. And it simplified it by not calling those helper methods and just doing that little simple math in line, which was great in theory, but of course lost all of the validation to ensure that it was kept up to date. So I was talking to a friend of mine on the team, and I said, well, we can do a source generator for this. So this is the new call to validate. All you do is pass in this enum. This will do all of the validation that it used to do. So the reason I'm in Visual Studio for this is to show off some of the features of Visual Studio. I can actually press F12 and I can go to definition on this validate method. And let me just put it side by side with my code. I missed. Oh no. Oh no. I think WebEx is not liking that. Okay, we're going to leave it side by side with the code there. And actually, can you see that? That's oddly enormous. There we go. Okay, so this is the validate method that is generated for this simple enum case, which is this one over here. And as you can see, the actual validation is just as simple as it was before. It's just a minimum maximum. The difference is we're not passing in the minimum maximum anymore. This just knows. Let me see if I can get this to work. Okay, cool. So watch what happens when I add another value to this enum. I type a comma, nothing happens. I'm going to type in the word third, but look at this one and watch what happens. As soon as I type T, the compiler is now generating my source again, because of course it produced a new compilation. So even though I haven't finished typing the name of this enum, which I will, it's already updated this to say 2. So gone is me having to pass in what is the maximum value for this enum. My source generator knows because it's looking at my code and it's getting the symbol information and it's able to just output the right values. This example here with this complex enum type, you can see these ones aren't all neatly lined up. So this is doing between 3 and 4 inclusive, and then between 7 and 9 inclusive. If I change this to a 14, this generation now we're going to validate against 3, then we're going to go between 7 and 9, and then we'll go to 14. I can even change another one to 14, and it's going to know not to duplicate those values. It's changed this 7 to an 8, right? It can be super responsive. So we get this best of both worlds where our enum validation is now super fast. This is, basically as fast as it can be, is simple integer comparisons, I guess, although feel free to optimize this code if you want. But we also have these really simple call sites. We don't have to do any, we don't have to help this by passing in any extra information. There's no technical debt being added because every time this changes, we know our generator is going to run. You cannot change, right? I cannot change this enum without the generator running because the generator is run by the compiler, which is super powerful. So let me close this down and let's just quickly have a look at the source generators. So as I said, we implement iSource generator, that's fine. The way we find the code we want to sort of trigger off, in this case calls to that validate method, is we use a syntax receiver. Now this isn't the only way to do it, but this is the best because what this means is, so we say register for syntax notifications. What this means is the compiler, we tell the compiler, hey, I'm interested in knowing about the syntax of this project, And every time the compiler sees an item of syntax, any item of syntax, it will call this method. So this is the best way because this means the compiler gets to be efficient, right? Rather than me digging through every single piece of code in the whole project, I just say, let me know when you see a node. And if that node doesn't change, then it doesn't need to call me again. It knows all these things. And so basically what we do is we get every single syntax node comes to us and we just check, is this something I'm interested in? In this case, well, I'm interested in method invocations. So that's an invocation expression. I want it to be only an invocation of a method called validate, only if it's on a class called enumValidator or enumValidator. This is a little bit of the sometimes annoyance of using the Roslyn SDK or rather of using C# syntax trees, because they're so detailed. If you have enumValidator.validate or enumValidation, which is the namespace .enumValidate, those are completely different syntax trees. And so sometimes this does get annoying. You have to allow for both. There is a higher level of syntax, which is called I-operation, which sort of takes away some of this pain. So there are alternatives, but for this simple case, I'm just checking both forms. And then, so basically, if I find a call to a method called validate on a class called enumValidator that has 2 arguments, and this is really just belt and braces, I just add this to my list. I say, hey, I think I found a call. I think I found an argument to this validate method that I should validate. Add it to my list. So that's my finding of syntax, essentially. The compiler's going to call me. It's going to say, hey, here's a node. Go nuts. And then when we actually execute the generator in this generate method, all I'm going to do is I'm going to go through my arguments that I found. So I pull them out of my syntax receiver, say, hey, go through my arguments that I found, and I just process them. And then here I'm getting the enum type, doing a little bit, some validation. I check if it's a flags enum, and that's it. The way that source generators work best is if you think like you're writing a compiler. So a compiler has phases, right? We have a parse phase where we build a tree, and then we have a compile phase where we process that tree. Your source generator is best if it can do the same thing. So in this case, I am building up these enum validation info objects, and these enum validation info objects are the thing that goes through, and so this method here finds all of the members of my enum. So I'm building up all this information, but you notice I'm not generating any code yet. So after I get, if we go, whoops, back up here, where are we? So this line of code here is basically saying, go and build up this information, this library of information about what you're going to need to do, and then we process it. So firstly, if we didn't find any, then I'm just outputting a empty stub of a method, just so that something is there for IntelliSense to key off, right? So that users have an easier time. This is actually optional. You don't need this. But if we do find something, then I call the generate method. So I build up all my information, then I generate it. And then this is where I'm generating. And as you can see, these are just strings. And it's not the nicest looking thing in the world, but it's not that hard. I don't know, maybe it's just me. I don't find this that horrible that I want to use some kind of higher level object mapping. Maybe some people do, that's fine. But all this does, we output an XML comment, we output our method signature, right, which has the enum type in it. And then we generate our method body. And the method body is simply, there's 2 different forms. One is for flags, one is for non-flags. And all these things are outputting is this series of checks. So for flags enums, it's just 1. We get the total, the total sum of all of the flags, and we just validate. Easy. If there's ever a new member added to this enum, it's going to appear because it'll be part of this loop, which means our total will get updated, which means our generation gets updated. And then for non-flags, we just output all those little if statements you saw. So each little chunk of this is relatively straightforward. This method here is probably the most complicated, which is trying to work out the bands. So we've got, 1, 2, 3, 7, 9. Well, that's trying to work out the bands in the enums. This was the most complicated code I wrote, and this one was the bit that took the most trial and error. The rest of this is pretty straightforward, and the power that you end up getting in terms of how simple this is, but how safe it is, and how no technical debt it is, I think is a really, really good win and a really big argument for this sort of thing. And that's basically me. If there's no other questions, I'm going to show this slide for no reason. I'm happy to run through anything else. We've got about 5 minutes left. So if anyone has any questions, feel free to chuck them in the Slack. Yeah, hopefully you may be interested in source generators, let's say. I don't expect anyone to remember any of the things that I actually said there, because using the Roslyn API can be sometimes painful. It's good to refer to other blog posts and things as you go, but yeah, there's certainly lots of possibilities.
Do you have that particular example that you gave us there, David, as a repository or something available in GitHub?
I don't. That's not about. I can put it up. It is. It's an open PR on the WinForms repo if you want to have a look. But yeah, no. I can just push this as it is. I will do that, and I'll put a link in the Slack.
It's an excellent example of the power that you can do and how to set it up. I really appreciate that.
Yeah, I really like this one because so in the PR. Oh, hello. In the PR for this, one of the first comments was like on this line of like, hey, this approach is too simplistic. What if we add a new enum value? And you really, like, I always think of that Back to the Future quote of you're not thinking fourth dimensionally when they're talking about driving off the bridge and Marty's like, but the bridge isn't there. It's like, it will be. It's kind of a little bit mind bending sometimes to think about this of like, you have to call. So actually the other thing I can do, which is interesting. So if I comment out this method here, there's no validation method for this enum type. So I have to call this method blindly, knowing that, my safety net will catch me. And then I have to not worry about the fact that this method only validates two things. Again, it's that safety net of they will be there if they need to be, which is kind of, it takes a bit of getting used to think that way. So yeah, I'll put up this example. That's totally cool.
That'd be awesome. Cheers.
No worries.
How does this align with the linker?
The linker. So the interesting thing is this should in theory work really well with the linker, because anytime you remove reflection and write can generate the code, that generated code is using whatever methods and properties you are getting from reflection, it's using them for real. So you don't need to tell the linker that they're being used, because they actually are. So this should work really well with the linker. It'll be very interesting to see what happens in terms of what internal Microsoft things will be rewritten to use source generators. So things like ASP.NET endpoint routing, even Razor, Blazor file generation could be rewritten with source generators. And there's pros and cons to all of that. In particular, that's where some of the concerns about you can't have multiple come up. So for example, if ASP.NET routing uses a source generator, then you can't use a source generator to generate routes, because those two things won't see each other, right? The ASP.NET one won't be able to see your generated code. So it'll be interesting to see how that sort of folds out. But yeah, in terms of the linker, that all happens on the IL after the compilation. So this stuff plays really well with it and can actually, I think, be a big help.
Awesome. Cheers.
No worries. If there's no other questions, I guess you can go get another coffee or whatever it is we do in these virtual conferences.